Math 1332, Chapter 2, Set Theory, Section 4, Using Sets to Solve Problems. Video 1, Example involving two sets. What you're about to see is very similar to what we saw in the last video in the previous series for Section 3. But this one is not really focused so much on a formula for the cardinality of the union of two sets, as it is focused on using a Venn diagram to help organize your information. So let's take a look at this one, which honestly looks like a word problem you might encounter if you have to take a standardized test like the GRE or something like that. GRE meaning the Graduate Records Examination. Basically, it's the SAT you have to take to get into graduate school. And yes, it has math on it. All right, let's take a look at this one and see if we can organize the information that we're given, illustrate it using a Venn diagram, and then use that illustration to help answer the questions that were being asked. All right. And as we're reading, I'm going to highlight the important information. In 2015, there were 40 states that had some form of casino gambling in the state. All right. 44 states that sold lottery tickets of some kind. So as opposed to casino gambling, and 36 states that had both casinos and lotteries. Now, there's something implied in this problem that you might not know if you're not a citizen of the United States of America, or you might not know even if you are, which would be kind of embarrassing, and that's the fact that there's a total of 50 states. So our universe will be the set of all 50 states. Draw a Venn diagram to represent the survey results, okay, and find how many states have only casino gambling? So there's question number one. How many states have only lotteries? And how many states have neither? All right, well, let's organize all the information that we're given. Let's say that the states who have casino gambling is C. Let's type this until I have to write it. Let's let capital C be the set of states with casino gambling. And I guess capital L is a good letter for the set of states that sold lottery tickets. Okay. And again, even though it's not explicitly stated, also we can say that our universal set is the set of all states. And again, this is, I'm assuming this is in the United States, but maybe that's just me being, nationalistically arrogant. Nowhere in here does it say that this is in America. I'm not sure how many other countries have states, much less at least 44 of them. But if you give me 1 second, I'm going to look at the source of this problem, if it will quit acting goofy. Nope, nowhere in the source does it say in the United States. So we're going to make that assumption. Otherwise, we can't really know the size of our universe. So we'll clarify a set of states in the United States. And just to make the question a little bit more specific, there, problem solved. All right. Okay, so now that we have our sets defined, and we're being asked how many this, how many that. That means we're being asked about cardinality. So let's document everything we know in terms of cardinality. Starting with the cardinality of the universe, there are 50 states in the United States of America. We're also told that 40 states had some form of casino gambling. So, and I realized by editing that it threw my highlighting off, but oh well. The number of states that have casino gambling is 40. The number of states that have lottery tickets is 44. And the number of states that had both, and since both means they have one and the other, the word and is there, that would be the intersection. Number of states that have casinos and intersection, lotteries, is 36. But what are we asked to find? What are we asked to find? In terms of cardinalities, how many states have only casino gambling, meaning casino gambling but not lottery. Well, we can actually write that by saying the cardinality of those that have casino gambling, so C, and intersection, not the lottery. So how can we type not a lottery? By writing lottery complement. Remember, complement means you're outside of that set. So C intersect L complement means casino and not lottery. And we're also asked to find how many have only state lotteries. So the cardinality of those that have lotteries and not casinos. And how many states have neither? So the cardinality of not a casino and not lottery. Well, there's a lot of information to find. And I'm a little bit concerned because we don't have formulas for any of these. Could we build them? Yes, we could. Are we going to? No, we're not. So how are we going to find all these cardinalities? Well, the trick lies in the very beginning of the question, which I did not highlight, but does say to draw a Venn diagram. So let's see if we can get that drawn. We'll draw a little rectangle here. And let's put a couple of circles in there for the two sets. These circles do have an intersection. In fact, their intersection is quite large. And for everything else, I'm just going to draw it by hand. We know our universal set is the, oops, come back here. We know our universal set, come on. Our universal set is the rectangle. One circle is the number of states with casino gambling, and one is the number of states with lotteries. Now, normally when we write things in a Venn diagram, the things we write are actually elements, but you can modify a Venn diagram. So instead of listing individual elements in the Venn diagram, I'm going to take the font size down. Give me 1 second. Instead of listing individual elements in the Venn diagram, we can list the cardinality of each region. And I think we're going to do that. 1 second, folks. Where's the thing? There it is. Sorry, I had to pause, take care of some personal business. All right. So in the Venn diagram, we're not going to list 50 state names. That would be silly. They don't fit in there. But we're not concerned with the individual states. We're concerned with cardinalities. So for each region, which I'm about to number in red, for each region, I'll learn to use Zoom one of these days. For each region, we're going to list cardinalities. Now, to do this, you know, it's getting kind of crowded here. I think I'm going to pause and draw a better picture on the next page. All right, it's a little bit better. Same Venn diagram, same given cardinalities over here, same things we're being asked to find over here. So how do we do all this? Well, as mentioned before, we're going to put cardinalities in each region, but we need to figure out which regions represent each set that we're given and each set that we're asked to find. For example, well, the universe is all 4 regions, and I didn't label region 4. So we already know that the universe is all 4 regions, which means that the 4 numbers we're going to write in the Venn diagram have to add to 50. Which regions represent circle C? Regions 1 and 2. So what does that mean about that 40? Can we put it here? No, because we would have to add it to the number there. Can we put it here? Excuse me, can we put it here? No, because we would have to add it to the number there to get the cardinality for C. That 40 has to be split up into 2 numbers that represent regions 1 and 2, but we don't know what those numbers are yet. The same thing for region L, whose cardinality is 44, excuse me, set L, whose cardinality is 44 and is represented by regions 2 and 3. So the 44 has to be split up into 2 numbers, but we don't know what they are yet. But what about the intersection? The intersection is region 2 and region 2 only. Now, why is this important? Because this 36 represents the cardinality of a single region, we don't have to split it up. We can just put it right where it belongs, which is the 36. We'll answer these questions in a minute, but let's think about what we already know. We know region 2 has 36 in it, which means everywhere there was a region 2 before, we can pretend there's a 36 in it. And now let's go back up to the cardinality of C being 40. I need two numbers that add up to 40, and one of the numbers is 36. So how would we find the other number? How would you find what to add to 36 to get 40? Subtract. In region 1, we can do 40, which is the total of regions 1 and 2, cardinality of circle C, minus 36, which is the cardinality of region 2, and we get 4. Now we have a total of 40 in circle C. And we can do the same thing for circle L, because in circle L, the two regions have to add up to give 44. So to find region 3, which is the missing piece in circle L, there's got to be a total of 44 in circle L, which we saw right there. But we can take away the 36 that's already in region 2 and the football in the middle. 44 minus 36 is 8, which means 8 states go here. And if we check, there's a total of 44 states in set L, 36 plus 48. And there's a total of 40 states in set C, 4 plus 36. And there's 36 in the intersection. So we've just drawn a picture that satisfies 3 of the 4 criteria that we were given. But the only one that we haven't figured out yet is what to do with the 50 and what goes in region 4. Well, the 50 represents the universe, which is made up of all 4 regions, which means that we can find region 4 by saying, well, it's all got to add up to 50, but let's take away the ones that we already have, minus the 46, minus the 36, and minus the 8. Equivalently, you could add 4, 36, and 8, and then subtract it from 50. In fact, I think that would be a little bit easier. Symbolically, it would be written like this, the parentheses meaning add all these numbers first, now subtract the total from 50, which is a little bit easier. 4 plus 36 is 40, plus 8 is 48, 50 minus 48 is 2. There are 2 states out there. So with the given information, I've not only drawn a Venn diagram, but I've written a cardinality for all the regions that satisfy the 4 given conditions. Total of 50, circle C totals 40, circle L totals 44, and the intersection is 36. And now that I've got all the cardinalities of all the regions, I can answer my questions. The first question was, how many states have casinos but not lotteries? That's like saying, and we've already got it written here, how many states are in circle C and not in circle L? Well, which region represents inside of circle C but outside of circle L? Region 1. And we don't have to calculate, we just simply have to observe. There are 4 states that have casinos but not lotteries. And the same thing for the next one. What's the cardinality of L intersect C complement? Well, L means inside circle L, intersection means and, C complement means outside of circle C. So, which region is inside of circle L but outside of circle C? Inside of circle L but outside of circle C. That would be region 3. The cardinality of region 3 is 8. There are 8 states that have lotteries but not casinos. And for the last one, the cardinality of C complement intersect L complement. That means what's the cardinality of the region that is outside of circle C and outside of circle L? Well, which region is outside of both circles? That would be region 4. And there are 2. And now we can answer all the questions. How many have only casino gambling? 4. How many have only lotteries? 2. I think it was 2. No, 8, excuse me. And how many have neither? 2. course, this is back in 2015, so I don't know how current these numbers are. It looked like a lot to do, but it wasn't. It was a lot to figure out how to do. But once you figured out how to do it, it's actually pretty straightforward, as I'll show you in the next video.